Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we are going to introduce a regular expression function to match portions of values within fields that can be applied to both rules in YARA-L as well as search. The function re.regex uses re2 and is equivalent to enclosing a string in forward slashes. In fact, we introduced this concept early in our video series, but now we are going to revisit its functional equivalent. The syntax for this function is re.regex followed by the field we are looking within and the re2 expression that we are matching on. The re2 expression will be enclosed in backticks. re.regex is a great way to identify values of interest, particularly in fields that contain user-inputted values or places where folder structures reside and there's some variability. re.regex by itself is not used with a placeholder or outcome variable. It returns a Boolean value. Let's take a look at it in action. Our example rule is detecting process launch events that have a target process command line value that contains a user input of netuse followed by a few different window shares, $, IPC$, and admin$. The first time we run our rule, we are going to use the syntax field equals / followed by our re2 expression and closed out with another /. Notice when we test the rule, we get 8 detections, and we can see the command line values in our results. Let's change our regular expression to use the equivalent re.regex function to perform the same task. Notice this time we do not have field equals value, but the field and expression within parentheses. The regex is enclosed in backticks, and when we test it, we get the same detections as we did in the previous test. Both methods that use regular expressions are valid. It's up to you to decide which one you want to use. Now, it's worth noting that when using the / around the re2 expression, that we need to escape any forward slashes in our expression with a backslash, whereas with the re.regex function, because it is encapsulated in backticks, we don't. So, if we wanted to look for netuse commands that have a /delete switch, we would first need to add a backslash before our forward slash that accompanies the delete switch. Notice when we test our rule, we get 4 detections. Now, when we swap this for our re.regex expression, we don't need that escape character, and when we test, we again get 4 detections. All right, we also mentioned that re.regex can be nested. Let's take our rule and add an outcome statement. We will keep our original regex statement in the event section the same, that is, looking for all 3 window shares that are called from netuse. This time, we will add an outcome statement that marks the events with the admin $ as yes and the others as no. In this example, we are using if then else and nesting the regex function and evaluation within the outcome. When we test this rule, we get the same 8 detections we saw before, but now we have an outcome variable that contains the values yes or no, depending upon the contents of the re.regex function. We could then take that outcome variable and add it to our condition section if we wanted to further narrow the alerts we receive. As you can see, re.regex can be used in the same way as UDM field equals / value /. It returns a Boolean value and uses re2 syntax. It can be nested within an if-then-else statement and is most often used where fields have variability due to user input or folder structures, but it can be used elsewhere as well. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.